flexibility that are required in terms of rolling out such a system. So where do I have to point to actually? Which direction for the forward? Here it is. Okay. My key speech, as I said, is about the flexibility aspects of a metadata management system. What are really the aspects to look into in key ingredients actually to realize this flexibility for metadata management systems? So let me first put this a little bit into a wider context here. The overall market environment is actually changing quite rapidly, so it's a quite dynamic market. Standardization is emerging, but it's fair to say that to some degree it is still a moving target. And in terms of bringing an MDM system really into a live environment in the utility space, it is also clear that utilities cannot afford actually in selecting a very business critical application and system that is not open and is not supporting change, it is not flexible in terms of moving into the future. Therefore, it's all about flexibility in this overall context. This means we have to make sure that MDM systems are going to support obviously the current needs as well as the anticipated future needs. It has to be a very open system that integrates very easily with existing systems and processes. And we have to make sure that all future changes and needs are actually adequately taken care of. And there are quite some architectural concepts that are around, I would say, for 2 decades now. A lot of those concepts actually have been developed in the telecom industry. There are quite some similarities, actually, if you compare metadata management systems also with telco level and telco grade systems and network management systems in this space. And I would like to line out some of the similarities and some of the concepts that we propose to apply here then on the metadata management side. So when I'm talking about flexibility, then I would like to basically bring this into 3 dimensions. So first of all, the first dimension, the blue case here, how is the MDM system actually going to solve existing needs and is ready to evolve moving forward? And this is about handling, on one side, if you look at it from a global system point of view, handling different individual market needs, the ability to mix and to handle different types of applications, so not only in the residential space, but also in the C&I space, or in a potentially mixed mode of operation, and how fit and how open it actually is the architecture to support future needs going forward. The second key dimension where we have to look into here is from an integration possibility, how easy does a MDM system integrate into existing landscape and also into a evolving landscape that is surrounding the MDM system. The MDM system can never be seen in isolation. It has to be seen in the context of surrounding systems. So this means integration and system integration towards, for example, existing enterprise systems in an environment. But also integration towards business integration, towards business processes, and integration into specific market needs and market environments. The evolution and openness of the system is going to be a key. So this means adaptation to changes, actually unknown changes at this point in time. I think nobody is able to predict today exactly how the landscape is going to look like in 10 years. So this means openness and adaptation to business changes, evolving new business models, to market environment changes, as well as new use cases that are going to be required. I will walk you through those three aspects and also propose measures and architectures and proven concepts on how those challenges can be addressed. So let me start with the first part here on the capabilities on how to solve functional needs, today's functional needs, evolving functional needs, as well as market needs. Let me first start a little bit to look at it from a broader perspective into the different regional markets. So if you look, for example, into North American markets, there's a clear need here to interact with multi-speak capabilities. So this is around for quite some time. We have more than 600 utilities that have actively embraced the multi-speak environment and standard. From the key use cases that we see in this environment, it's very much about demand response use cases. Outage management is going to play a very important role in the North American market due to the characteristics, actually a lot of overhead lines, severe weather conditions. So outage management is going to be a key important use case. Whereas if you look to the European markets, here data privacy and security, and some of the speakers beforehand have touched this, are going to be key use case and key ingredients that have to be supported by MDM systems. We have to deal here with a deregulated market environment, and actually there's also an ongoing trend to integrate also smart grid data and certain applications also into a metadata management system. Whereas if you look more to emerging market landscape, Latin America's, Asia Pacific, their key use cases are definitely around non-technical losses, how to improve the revenue situation there, and this is going to be a very strong trend. So how can this be harnessed, and what are key aspects to be looked into to achieve now the flexibility element to serve those different markets? And this is the combination of basically a strong platform foundation, but then three key elements that we will bring and want to bring here into this landscape. It's about pre-built interfaces, it's about pre-built use cases, pre-built configurations. So what do I mean with pre-built interfaces? It is about standard head-end connectors to serve a quite diverse and colorful communication landscape and infrastructure. It is about standardized and pre-built interfaces, for example, the enterprise connectors to connect directly to enterprise systems like SAP via MDAS. It's about pre-built interfaces for the market interaction. For example, the P4 interface, one of a typical class of interfaces supporting this kind of interaction. But we need also pre-built use cases, pre-built standardized applications, whether this is non-technical loss, whether this is demand response applications, whether it is certain workforce management applications that have to be pre-built in and pre-configured, ideally to be part of overall software package and to be enabled very quickly. Pre-built configurations, and what I mean here is pre-built configurations in terms of local market support. This can be rather simplistic in terms of specific language supports. It can be specific tariff supports that are required for certain countries. It can be specific data models that can be implemented then as pre-built configurations. Taking all those elements together basically will result in what we call solution accelerators. So the strong platform foundation, pre-built interfaces, use cases, and configuration will lead ultimately to a very fast rollout time from a utility perspective. And we're talking about a magnitude of a factor of 5 to 10 really of speeding up rollout if you go into such a model and such an architecture that support this. So looking a little bit into the different architectures and high-level architectures on how an MDM system can be built. This is what we call the smart data matrix on the horizontal axis, and this is different use cases for C&I and residential. Some utilities might vote to split this up into either separate residential rollout and C&I rollout from an MDM perspective. Some other might want to combine this in one system, so that's the horizontal axis. Whereas on the vertical axis is about whether you're going to separate the MDM system and the metadata collection. So this gives basically 4 principal architecture ways that can be rolled out. And choices actually towards individual architecture are driven by several aspects. Some of them are actually competing aspects. From a pure IT landscape and integration point of view, normally you would look for a separation of system. You would try to isolate concerns somehow. You would try to isolate single point of failures and try to interconnect on the basis of standardized interfaces and standardized protocols. From the business needs, you would like to have a maximum amount of cost saving, very efficient total cost of ownership and life cycle cost. It would drive more towards an integrated approach, MDM and data collection in one system. It's very important to understand that from overall design, if you have a system that can combine MDM and MDC in an effective way, you can always serve the other use cases, whereas the other way around, to combine separated systems into an efficiently, let's say, glue together system, this approach is not that easy. So if you have a combined system, MDM and MDC, and if you add then in particular full multi-vendor capabilities to this and full scalability elements to this, then we have a very interesting value proposition and a highly flexible system. So, solving future needs. What are the key challenges that we see here in this evolving landscape? So first of all, big data is going to come. It's coming from a sheer amount of devices. It's coming from the amount of data per device, and it's coming from new devices. And if you look really into the performance characteristics here, then performance has to come in several aspects. It's performance on the data acquisition side itself. It's performance in terms of storage that the MDM system has to provide. It's performance in terms of data validation capabilities. And it's also the performance to exchange data in a highly effective way with the surrounding systems in the IT landscape. So this means the MDM has to support the ability to scale up, and this is more the hardware-related part on the CPU and memory side, but also to scale out and to move into a rather distributed environment. Data analytics is going to be key, so to really get the large amount of data under control and to get actionable information out of the overall data. So therefore, analytics and data mining options and capabilities are going to be key ingredients of a flexible MDM system. Smart grid data. We cannot look at this from a meter data management and pure meter data and smart grid data in complete isolation. So those data will depend on each other, will also have to be correlated. If you look, for example, to outage management and early alarm management, if you look to proactive maintenance type of concepts that are well known and established in the telco sector, then it's about taking a broad enough view on the overall set of data, also embracing smart grid data. So it's therefore important that we look at it from a more data unification platform point of view rather than a pure metering data point of view. So integration capability, I said already, the MDM system cannot be and must not be seen in isolation here, but always has to be seen in context with existing systems and in integration with existing systems and landscape. And there are also here proven concepts, how this can be done, proven concept out of other industries like the telco sector, how such an integration can be done in a rather smooth and effective way. So integration challenges, well, obviously to take care about the legacy systems that are around and how can this done in a very effective way. It can be done in a very effective way if an MDM system has an open architecture, provides open APIs, provides SDKs for ease of integration towards existing legacy systems. We obviously are still in a world where also file exchange is a key element, so this has to be complemented by a very strong import and exporter framework and the ability to, wherever needed, to fully customize then interface support towards existing systems. This would also have to rely in terms of being fast and to be efficient on this open architecture and on the API as well as SDK capability. The ability to exchange actually data and information with existing systems and with existing enterprise systems will be very much eased by a service-oriented architecture. From a communication flow point of view, rather than having multiple systems in a very complex point-to-point mesh communication flow, this is supported then by enterprise service bus and obviously by standardized industry standard messages like the SIM model. The target ultimately is from all the integration aspects that a customer, that a utility wants to get a system up and running very fast. So, and this at the right cost points. And therefore, It's about standardization of whatever can be standardized, should be standardized. So head-end connectors, interfaces towards the enterprise landscape, towards SAP, for example, via MDAS, and to support and a strong support of industry standards with SIM, and like in the US with multi-speak. So it's all about reducing time to market. It's all about making sure that the individual utility can have a system up to speed and running at a very fast pace and at reduced time and costs. So looking at this from a business integration and from a business process integration, the challenges are that we will have to deal with a large amount of different data sets. So data unification is going to be a key element. So this means specific data sets or data objects, actually generic data objects, for example, for meter devices or for certain asset classes, so that based on such a data structure and data objects, there can be a seamless integration then also horizontally between different systems, for example, on business processes that can span from a SAP system over MDM system over, let's say, as a typical example, a workforce management system. And it's really about the ability here to integrate this seamlessly and very fast from a new business process point of view. And no matter, and it should not make a difference actually whether those business processes are mapped then into an MDM system, into a pure MDM system, or whether those business processes are mapped then in the complete chain of systems from an MDM system to a workforce management system, or for example to an enterprise management system. The ability to exchange market-related messages is going to be very important, especially in a deregulated environment. So here, file-based messaging still going to be supported. That's obviously the current legacy that is around, but also then here, standardized market connectors, whether this is interfaces like P4, for example, or also here then support of standardized or of standardization in the context, for example, of EBIX type of message exchange. So, evolution of a system moving forward. What, 3 minutes? Evolution of a system going forward. The MDM system, it's a living organism. It has to be flexible. Once deployed, it has to react to changes. It has to react in a flexible way when we're talking about upgrades and updates. And this means it must not interrupt the business flow and operation. This can be achieved also here with downwards compatibility of the APIs. So in particular, that we do not touch or nearly don't have to touch, let's say, a customized environment, so that we shield downwards on the API compatibility, that we provide as an industry proper migration scripts, proper pre-production systems where those upgrading paths are going to be tested out. Business changes will have influence also then on the related data structure. It's clear that we don't know exactly today what is going to happen, what are new evolving business models, and therefore version management is going to play a key role as well. So think about meters that are going to be updated in terms of functionality, firmware updated, new functionality is going to be added, for example prepaid functionality. The systems will hold then historical data of meters that historically did not even know what prepaid functionality is. This means an MDM system has to make sure that there's proper version control to handle this kind of data. So bring this all together. How do we see architecture and the blueprint of a flexible meter data management system? So first of all, a strong platform foundation with the scalability, with the scaling ability, scaling upwards as well as scaling outwards horizontally. Support of standardized information model like SIM, supporting a data unification layer, whether this is pure meter data or grid-related data, proper version management that I've just mentioned, but also then data correlation and data aggregation capabilities. A strong set of integration fundamentals that I've touched based on an open architecture, open API, SDKs, pre-built connectors. Well, I would nearly call it use cases to go in a very fast and seamless integration of new customer use cases as well as pre-built use cases, all relying on interfacing towards the integration layer with a strong API layer. And this is to be combined then with local market solution accelerators to enable very fast rollout of such solutions. So it's all about flexibility, because agility and speed will be required in the market. And such a high-level architecture will basically present all the ingredients that we believe are necessary to move forward in this market. It's about more and new devices. It's about that will certainly create more and new data, new operational use cases, as well as new customer use cases that will be required with new business processes, new business models. Standards and regulations are not going to be settled in all markets, so a certain element of flexibility is needed here. The need really for intelligence, the need for data mining, harvesting, and interpreting the data is going to increase with the large amount of data that we're going to face. And this kind of architecture can support this. So this was my very short excursion into how we believe a flexible MDM system should look like, and how, let's say, proven architectural concepts of other industries can be applied towards this quite exciting field. Thank you very much for your attention. And we might go for questions now or during the break.
Okay, thank you very much, Bernd. What I actually would suggest, Bernd, if you're happy with that we wait until the break. So we have one more presentation, and then after that presentation, I would then ask you to hang around and you could take questions, comments.
Yep, that's fine. Pleasure.
Welcome. Yeah. Thank you very much, Bernd. So our last presenter is Gobi Gol, who is going to talk about different deployment scenarios. And Gobi Gol is Business Development and Solution Manager at Red Data Communications in Israel. So welcome, and